wanted to make sure I did the gravitational force problems here just to give you a little bit of an idea of how they work. So, we have the moon, we have the earth, and we want the force between them. So, I would call this the mass of the moon, I would call this the mass of the earth, and we can actually go ahead and calculate the force of gravity here as G, which is 6.67 times 10 to the negative 11th. And then we're going to multiply this by the mass of the Earth, 6 times 10 to the 24th kilograms. That's like a mole worth of kilograms. It's a lot. And then the mass of the Moon is 7 times 10 to the 22nd kilograms. And we'll divide this by the distance squared, which is 3.84 times 10 to the 8th. And then that's squared. So let's go ahead and get that force of gravity. And when we actually work that out, quite a bit of math here. So 6.67 times 10 to the negative 11th times 6 times 10 to the 24th times 7 times 10 to the 22nd divided by 0.84 times 10 to the 8th. That's giving us, if I really round here, I'm getting 1.9 times 10 to the 20th newtons. It's quite a bit of force. All right, now we're going to repeat a similar calculation for the sun and the earth, sun and the moon. The sun. We're going to now look at the force of the sun as it pulls on the earth. So that's going to be Fg equals G times mass of the sun, mass of the earth over the distance squared. And that's going to be 6.67 times 10 to the negative 11th times 2 times 10 to the 30th, that's the mass of the sun, times 6 times 10 to the 24th, all over 1.5 times 10 to the 11th. And we're going to go ahead and square that. And I'm going to move this stuff over here. Excellent, and that as well. All right, so when we get this force, the answer that we'll get so just multiplying the numerator out, it's a pretty big number. And then we're going to divide by the denominator, which is 1.5 times 10 to the 11th squared. And that's giving us a force of, 3.6 times 10 to the 22nd newtons is what I'm getting. Now, if we're comparing the force kind of as a ratio, you notice that this is 20 and this is 22. Kind of a shortcut here is I'll just look at the powers of 10. So this would be 10 to the 22nd over 10 to the 20th. So it's about 100 times bigger. And I should have really used the moon in this calculation. So actually, I'm just going to worry about this. But so force of the sun on the earth versus Earth and the moon. It's about 100 times bigger force, just to kind of compare. All right? So that is just the last page on the second part of the practice test. The first one and the second one are similar enough that I'm just going to post this video for the second practice exam, and I'll put this file in the uploaded files for you to check your work against.